This problem is for Newton's second law, reassessment. This is for a cart on the track. Where there's no frictional force considered, and you have a massless string coming down to both masses. So that the tension is the same along the string together. If you know that this mass is heavier than this one, then you know it's going to accelerate to the right. This mass is going to make it accelerate down. So given both masses, you can be able to find the acceleration. Draw your force-based free-base diagram. Mass 1 is your normal force coming from up, tension, and mass of gravity, force holding it down. And for mass 2, you have your tension and your mass of gravity pulling downward. Start with M1. So we have X is equal to the mass times acceleration, because it's accelerating in the positive X direction. And then, so your forces in the X direction are just tension, because it's the only one going in the X direction, equals your mass 1 times your acceleration. And for your Y, it equals 0. Only forces acting in your Y direction are N and M and negative mg, because mass of gravity is always pointing down, equals 0, which those aren't going to be used. You have your second mass, this is your change in x, equals 0, because there's no forces acting in either x direction, and it's accelerating downward, so there's going to be no acceleration in the x direction for mass 2. So your forces in the y direction, there's T to your tension minus your m2g, mass 2 gravity, equals m2 times the negative acceleration, because it's accelerating in the downward direction. So if you come up here and you take your T, you can plug it in to this equation for this T, and you get m1a minus m2g equals m2 times negative acceleration. If you add the m2g to the other side, you can you're trying to solve for your acceleration, trying to get that by itself. So you can add that m2g over to this side, and then if you take your m2a and add it back over here, you add it to this side, you can factor out your a, and you're left with the m1 and m2 equals m2g. That's it right there. And then you're trying to get acceleration by itself, so you divide this all together to the other side, and then you're left with acceleration equals mass 2 times gravity over mass 1 plus mass 2. And then your acceleration, your mass 2 is 45 grams, and times 9.8 newtons per kilogram, which is your gravity. Kilograms are going to cancel out over your mass 1 and your mass 2, which those going to leave you the kilograms on the bottom, so you're left with newtons per kilogram. So your answer is 5.7 newtons per kilogram. And this results in both masses having the same magnitude of acceleration, but just in different directions. So the acceleration might be the same, it's just happening in different directions, since it's the same string. And that would be it.